And so we can clear this, and you can see that this can happen, no matter what the denominator is. You can use the quadratic formula to solve, or if you want to keep it factorable, like if x here at 4, we're going to see them at plus or minus 2, right? In this case, y equals 1 over x squared minus 4, right? We're going to see this again, difference of two squares gives us these two vertical asymptotes. We can clear that and go all the way. We'd have to go to 9 for our difference of two squares here. And then now we see, oh, the vertical, and I'm just doing the difference of squares because they create whole numbers, but you can see with the slider, right? So here we have, right, x equals positive 3 and x equals negative 3, right? Vertical asymptotes. And so I want you to be able to see it in the graph, but then also see it, right, see it in the equation. So because this positive 3 and this negative 3 would make this denominator 0, that's when we get these two vertical asymptotes. So again, just kind of repeating that same idea. And so we can see that with the whole numbers, right? But I want you to see that it's still, even, this is not going to be so it's nice, a whole number to something factorable, but it still has those vertical asymptotes because these are real numbers. They're not imaginary numbers. They just are not a whole number. Whereas when we go here, right, if we tried to solve that for 0, they would create those imaginary numbers, right? X squared plus a number, plus a positive number then we don't need any vertical asymptotes because this denominator, the only thing that makes it 0 is going to be those imaginary or those complex numbers.